Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 26th of the January daily LeetCode challenge, and it's a hard question. After a long time, we are getting a hard question. So from last few days onwards, we're getting some good medium level questions, and finally we have a hard question today. Okay. So yesterday's question was the Fang level question. Just in case if you have not seen that, I'm talking about day 25 of the January daily LeetCode challenge. If you have not seen day 25th question, please go and see that. It's a very nice question. It was one. It you can tell that it is one of the Fang level interview question. Okay, you can please check that out. Now coming to today's question, it is a hard level question. So see, this kind of questions you will not be able to solve without hints. Okay, because it's not about just the algorithm. Even if you know the algorithm, still you need a lot of insights to solve this kind of question. So for that reason, like if you are a beginner, I will say that, see, do not try it out just like that. Okay, like try to learn the ideas involved, only then solve this kind of question. Again, I'm repeating, it's not based on algorithm. Even if you know the algorithm, still you may not be able to solve this kind of question because it needs a lot of background about this particular thing. Okay, let us, if the question, if you see, I will say the show you the question, but yeah, after that you will need a lot of insight. So I have kept those insights ready so that in this video I will show you everything possible so that you have the right idea, and maybe then you can, just after seeing this video, you can stop this video when I start to show you the solutions. Stop the video there and then start your coding. Okay, that is something that I will advise you, because see, without knowing this concept, if you are trying your solution, I will say that you are wasting your time, because it's not that simple question and it's a very complex question. And even if you are able to clear some of the test cases with a brute force solution, still it will not be very helpful. I will say that very clearly. So first learn these kind of things. Remember, these are not algorithm related. These are just like observations. Okay, this you will get to know only if you dive deeper into this problem. So these are not related to DSA, right? Only this is specific to this problem. So learn these things and then maybe like try and code a solution. Okay, so let us quickly begin with today's question. So yeah, let me zoom in. Let us begin. It is day 26, and yeah, let's see the question. It's a hard question. 2127, maximum employees to be invited to a meeting. Okay. So as you can see, this question revolves around the topic of a round table. Okay. We have employees ranging from 0 to n-1. Okay. And they are to be seated around this round table. Okay. So let's see the question now. A company, okay, let me zoom in further. A company is organizing meetings and has a list of n employees. Remember, the number of employees are fixed, waiting to be invited. They have arranged for a large circular table capable of sitting any number of employees. Okay, so it's not, the restriction is not about how many employees can be made to sit around the table. The number is infinite. Okay, as simple as that. The employees are numbered from 0 to n-1. Each employee has a favorite person, and they will attend the meeting only if they can sit next to their favorite person in the table. Okay, so this is the main condition we have to think about. Okay, so first thing is that the employees are going to range from 0 to n-1. Remember, this is important. Why I'm saying is, when you see the input, no, these things will become clear to you. Remember, 0 to n-1, this number is fixed. Okay, each employee is numbered between 0 to n-1. Okay, each employee has a favorite person, and they will attend the meeting only if they sit next to their favorite person in the table. The favorite person of an employee is not himself. That is, a person will never declare himself as the favorite person. Okay, that is very clear. Given a zero index integer array favorite, where favorite of I denotes the favorite person of the ith employee. Okay, so let's understand this part. So see, this number tells that for employee number 0, the favorite person is person number 2. Similarly, for employee number 1, the favorite person is employee number 2 again. Similarly, for employee number 3, the favorite person is employee number 2 again, and so on, right? So the index tells which employee it is, and the value here tells the indexed value person wants to sit with which person. Okay, simple as that. Now, what is the question? Return the maximum number of employees that can be invited to the meeting. Okay, as they have mentioned, a employee will attend the meeting only if he or she gets to sit with their favorite person. Okay, as simple as that. And remember, since it's a round table, so a person will have two sides. Okay, left side and the right side. So in either of the sides, if their favorite person is being made to sit, only then they will attend the meeting. Okay, that is the constraint now. So you can see the example number 1. Okay, what is happening here? See, for the person number 2, if you see how many people are in lined up, employee 0, employee 1, and similarly employee number 3. Okay, all of them want to team with employee number 2. Okay, that is not possible, right? See, employee number 2 will have two sides, so I cannot accommodate three persons there. Okay, only two sides are possible, so only two employees can be seated next to employee number 2, in the left or right. Okay, so I cannot make three employees sit next to employee number 2. For that reason, we'll have to rule out one of the employees. Okay, so that's why the number is 3. Okay, and the final output is 3. You can go through the explanation, but yeah, sorry. So after I explain these topics to you, maybe we can come back to example number 1. We can try to see this again. Okay, but for now you can just know that it is not possible for three employees to be seated next to a single employee. Okay, only at max only two employees can be fixed to be seated for one employee. Okay, and so like that. Now you can go through other examples, but the constraint that I want to show is that, see this, the number of employees, that is the number of n here, is going to in the range of, is going to be in the range of 10 power 5. Okay, 2 to 10 power 5. And similarly, yeah, this thing we have already seen, a person can never be favorite person of himself. Okay, simple as that. And yep, these things are clear to us, right? Yeah. So now coming to how to solve this question. So for that, first of all, we will see some of the insights. So see this part, what all gonna happen. See, for example, okay, let me zoom in and let us see this. Now, see, there are two cases that are going to happen. Okay, if you have a pen and paper, please take them and write it down, because these are the only two cases that can happen. See, the case number one is the one diagram which you are seeing in green. Okay, so in green, what you are seeing this circle. So what can happen is, let us say a circle is getting formed. For example, see, 5 want to 6 with 6, 6 want to 6 with 7, 7 want to 6 sit with 4, and 4 want to be seated with 5. If you see, there is a circle getting formed. Okay, so the idea here is, in this case, you can, like, if let us say you are taking this circle as your answer, so the answer is going to be 4. Okay, because see here, we cannot break the circle. Okay, if we, even if you remove one edge, what will happen is the circle will break after that. Okay, so see, if I remove this edge, so 4 cannot come now. Okay, since 4 cannot come, 7 cannot come. Since 7 is not coming, 6 will not come, and 6 is not coming, 5 will also not come. So the idea here is, even a single edge cannot be removed here. So if a circle like this getting formed, so the answer in this case is going to be the number of nodes in the circle. Okay, answer is going to be 4. Okay, this is one possibility. Remember, the question is very simple, we have to find the max number. Okay, yeah, the maximum number of employees that can be invited. So this is just one possibility. What are the other possibilities? See this case. See, now we are coming to the topic of, circle with length of 2. Okay, what is that? See this case. If you see 8 and 9, what is happening? It is a double-sided edge. What it means, 8 want to 6 with 9, and 9 also want to 6 with 8. Okay, we have seen this example in example 1 also. Have seen this case. See here, 1 wants to sit with 2, and 2 wants to sit with 1. Okay, see this case. Index number 1, that's employee number 1, wants to sit with employee number 2, and employee number 2 wants to sit with employee number 1. Okay, so this example number 1 case falls in this. Okay, see here, 8 wants to sit with 9, and 9 wants to sit with 8. Okay, so if you like try to convert it into a graph, what you will get a circle. Okay, you will get a a loop, like a circle, right? That is, yeah, it's a loop kind of. Okay, repeating stuff, but the length is 2. Okay, because in the circle there are only 2 nodes. Similarly, if you see the other cases, yeah, the only difference between this and this is, here the length is 2, and here the length is more than 2. Okay, so these are the only two cases that we're going to get. Okay, a circle whose length is equal to 2, or a circle whose length is greater than 2. Okay, these are the only two cases that we're going to discuss now. Okay, why other cases will not come, we will see that now. Okay, so the green part which you're seeing here is the case where, okay, the circle is formed and the number of nodes in that circle is greater than 2. Okay, but in this case, the one which is seeing in pink, in all the cases, if you see, they're going to form a circle of, okay, of two nodes inside that circle. Okay, as simple as that, a circle with two nodes. So in this case, if you see 8 and 9, similarly, if you see 0 and 1, and 3 and 2, 2 and 3. Okay, maybe like what you can do is take this and add this in your test cases. Okay, and then you can, dig deeper into it. Okay, as simple as that. So now what we can do is, now we are clear that we have two cases. What is the case number 1? Case number 1 is when a circle is formed and the number of nodes in that circle are more than 2. Okay, that's case number 1. Case number 2 is that when circles are found but the length of a circle is 2 in each case. So in this case, if you see the, we'll take two examples, see 8 and 9, 1 and 0. Now 8 wants to sit with 9, 9 wants to sit with 8. Okay, so see, for 9 there is no other choice, that is, it just wants to sit with 8. Okay, for example, let's say 8 is present left of 9, but the right of 9 is still empty. Do you agree with me in that? So what we can do is 8 and 9 and 1 and 0. Okay, these two can be combined. Okay, for example, I will make 8 sit, then 9, and then after that 1, and maybe then after that 0. Okay, so these two can be combined in any way. Okay, they do not have any restrictions. Remember, that was not the case here. Okay, 5, 6, 7, and 4. See here, for 5 cases are fixed. For 5, one side 6 is going to be seated, and similarly for 5, the other side 4 is going to be seated. Okay, so both sides are fixed here. We cannot introduce any other person in between. Okay, as I mentioned, if I introduce any other person in between, the whole loop will break after that. Okay, so please see this case. This case is very different. Okay, here we cannot introduce any other node in between. Okay, it is fixed. The length is 4 is fixed. Either 4 has to be the answer, or we have to find an answer greater than 4. And there is no else condition in that. Okay, but in this case, if you see 8 and 9, we can add 1 and 0 also in that group. Okay, see, since 8 and 9 are coming, 8 only wants to be with 9, and 9 only wants to be with 8. So whoever is seated next of 9 doesn't matter. Okay, just 8 has to be there in one side, the other side anyone can be seated. So either one of the and 0 can be seated. Similarly, if you see 8, 9, 1, 0, 3, 2, and 11, 10, all of them can be taken together. Okay, they they do not have any issues as such. Okay, they can be like accommodated within a single group. Okay, as simple as that, because they are depend on each other. For that reason, their one side is empty. In that one side, we can make anyone sit. Okay, as simple as that, right? Now now in the case 2, see, case 1 is when circle is formed and number of nodes in the circle are greater than 2. Case 2 is when a circle is formed and the number of nodes in that circle are equal to 2. That is the case when this pink color circle will be formed. Okay, here if you see two directed edges are coming. Okay, a single edge is there which has double directions. Okay, two direction in it. Okay, double sided edge. Yep. Now in the case 2 there is going to be sub case. Now remember, in the case 2 where we are forming a circle of two nodes, there is going to sub case. Now what is the sub case? See, in this case if you see 11 and 10, okay, they can be seated with each other. But if you see, we can even extend further. See the case 11, if you see, though it has to sit with 10 only, but on the other side of 11 we can make some other people sit. See, in this case 11, see, 13, 12 and 11 are also there. Okay, since 11 has to be seated with 10, so on the other side 12 and 13 can also be accommodated. Okay, in this similarly for 10, the other side 14 can be accommodated. So the idea here is when you have a double sided edge like this, or when you identify a circle of length equal to 2, what you can do is for either of the nodes, try to expand as much as possible. Okay, so we have to go in the reverse direction in that case. See here, please pay attention. For 11, I am going the reverse direction. See, the edge is towards 12 to 11, but I want to go from 11 to 12. Similarly, from 12 to 13, I am, going in a reverse direction. Okay, I'm going to the reverse of the edge direction. Okay, similarly in this case, from 10, I am going to 14. So what I'm trying to tell you is that, see this case. Yep. So this is one such very classic example of this. Just let me zoom out a bit. Yep. So if you see, 12 and 15 are, self 12 and 15 are trying to sit with each other. Okay, so there is a double sided edge here, but if you see, we can expand it. Okay, see, for 12 the other side can be filled with 11, 7, 22, 4 and 10, because see, it's a like edges coming, right? Similarly for 15, if you see, it can be made to sit with 5, 14, 1, 10, 8, 3, 20 and 21 and 17. So the idea here is, for if whenever a circle of length 2 is formed, for each of the nodes, what we can do is we can see whether we can do a BFS and identify a very long path, the longest possible path after that. Okay, so from 12, whichever is the longest possible path, we will try to identify that. But remember, we have to go in the reverse direction. From 12, we have to go to 11. Though the edge is from 11 to 12, we have to go from 12 to 11. So we have to, move in a reverse direction. Okay, yep. And similarly for 15, if you see, we are moving in a reverse direction. So our aim is, whenever a circle is found whose length is 2, that is, in the circle there are two nodes. In for each of the nodes, we are trying to do a DFS or BFS, whichever we want, to identify the longest possible path. Okay, that exists. Okay, so from 12, 11, 7, 22, and on and so on. Right. Similarly, 5, 14, 1. Remember, we are we are not going to 19, because if we go to 19, we'll miss the other longer edges. Okay, so our aim is to find the longest edge possible from 15, and similarly from 12. Okay, then then see what is happening, we will take the sum of that. Okay, see here, 12 and 15, 2 is there. After that, what are, see, 18, 4, 22, 7, 11, we have to add them. Similarly, all the nodes from 17 till 5, we'll have to add them. Okay, so this is a sub case of the, as I mentioned, the case number 2. First case is when a loop is formed whose number of nodes in that loop are greater than 2. Second case is when a loop is formed, number of nodes are 2. But in the second case, there is sub case. If you want, we can expand further. In this case, if you see, 11, I am like moving in a reverse direction and, capturing 12 and 13. Okay, because they can be made to sit with 11. Okay, similarly for 10, I'm expanding 4. And similarly, if you like try to see the worst, best case that can happen here is, see this case. So idea here is, there are only two cases. Either this could be the solution, this green circle, or the sum of the, pink circles can be the solution. But in the pink case, there is a, sub case where you have to expand and see whether any expansion is possible from the each of the nodes involved in the two node circle. Okay, these are the only things that can happen. So now I am done. If you want, you can pause the video here and try to solve this question now. Okay, but as I mentioned, I will be showing the solution. Maybe if you want, you can pause the video and see. Okay, now see the solution here. As I mentioned, whenever a circle is found with nodes, with two nodes, we have to move in a reverse direction. So for that reason, now what we'll see is, okay, let me zoom in. For that reason, what you have to do is, we have to, you have to make a list of edges in the reverse direction. Okay, this I am calling as the reverse edge. Okay, let me show from starting. See this case, first we are taking the length of the nodes. So the nodes are going from 0 to n-1. Similarly, we are creating a, boolean array of visited sets. So this will tell you which all sets are visited, so that we do not visit them again. Okay, similarly, as I mentioned, there are going to be two cases. One case is where a circle is formed whose length is greater than 2. For that, see, remember, that also can be the solution. Okay, so for that reason, we'll also try to capture that. Okay, what is the biggest circle that can form, and how many nodes are it going to have? Okay, that also will try to capture in this. Similarly, we can also, what can happen is, see, in this case, as we saw, whenever a circle is formed with two nodes, we will try to expand further. Okay, so that the length of that is going to be captured in this. Okay, length involving length two circles. Okay, okay, let me do this here. Length involving length two circles. Okay, a circle of length 2, and after that, whichever nodes can be expanded, we'll try to do that. Okay, as simple as that. So see, either this could be the answer or this could be the answer. Okay, at last if you see, we are going to return a max of these two. Okay, we are ultimately returning a max of these two. So whichever among them is the max, that we return. Okay, so that is how we are starting with now. Yep. And this reverse judge, as I mentioned, this will be needed in order to do a BFS or DFS, whichever we want, whenever we are identifying a circle of node 2, okay, of circle of length 2. Okay, as simple as that. For doing the BFS by the nodes. Okay. Now, this I explained to you, we are going to create a boolean array to track which all nodes are already visited. This I explained to you. Okay. This again I explained to you. You can go to the comments. And then, yeah, reverse edges, as I mentioned, in the case of this, the blue circle that you're seeing, right? To explore that part, we need a reverse edges. Okay, as we can see, from 13 we have to go to 12. Okay, but we're going in a reverse direction of the edge. For that reason, we have to capture the reverse edges. Okay, as simple as that. Now, this is where we are storing that part. See here, for I in range, and then what we are doing is we are reversing the edges. What it means? See this case, for example, what I will do is, now I will try to see for 2 which all node wants to come with 2. That is, which all node wants to pair with 2. Okay, so that will give me the list for that. Okay, as simple as that. So if you see what we are doing, reverse edges of I. Okay, remember this is default dictionary. Okay, yep, this is default dictionary, and the well is going to be list. I'm doing favorites of I dot append I. That is, I will get to know that for this person, who all person wants to save with him. Okay, so this will give me a list of that. So in this case, if you see, I will get to know for 11 which all person wants to save with 11. So the answer will be 12. So we'll go and explore 12. Okay, something like that, right? This will be used when you're doing the BFS for a cycle of length 2. Okay, remember that part. Now, this is the BFS function. Okay, this is a simple BFS function. I also kept here a test case. Maybe you can uncomment it and try to explain, try to understand how this works. Okay, as simple as that. So what we are doing here in this, BFS, it's very, very simple basically. See what we are doing. I'm just declaring a max length. I'm declaring a queue. In this case, it is a DQ. If you want, you can even keep a single queue. You need not keep a DQ, right? First, I'm appending the current node. See, I will pass a node here, and I will pass a visitor set here. Okay. Okay, let me explain this also. See, the visited set in this case, for example, I'm talking 11 and 10. So the visited set will have 11 and 12. Okay. Then for 11, I will start a BFS. Similarly, for 10, I will start a BFS. Okay. My aim is to complete, cover the blue part. Okay. As simple as that. So since I'm keeping 11 and 10 in the set, I will not explore 11 and 10 again. I will explore 12 and 13, similarly, and 14. Okay. 12, 13, and 14 will be explored after that. Okay. So this set will help me to avoid repeating the nodes. Okay. Now, max distance I'm setting a queue. This will see for BFS require a queue, right? Same setup. Okay. I'm keeping the node and I am keeping the distance here. Okay. The distance 0 initially. Till there is single element of queue, what you have to do, just pop the element out from the left. This will give me the current node and this will give me the distance from the current, okay, from the starting node. Okay, then if for every time when you swapped, I'm just going to see whether this is a maximum distance or not. So I'm just comparing with the max distance. Okay, I'm just comparing the max distance. If the current distance is more than max distance, just update it. Okay, then go to all the adjacent nodes of the current node. Okay, for the current node what you are being popped out, go to its reverse edges. That is, see this case for 11 the reverse edge will be 12. Okay, similarly for 12 it will be 13 and so on, right? So for the current node, go to all the adjacent nodes traversing the reverse edges. Okay, just see whether the adjacent node is already visited or not. If it is not visited, then in this case append it to the queue with a distance of +1. Okay, with a distance of +1. As simple as that. Then again the same thing will be popped out and so on. And whenever something is popped out, we are trying to capture the distance. Okay, yep, and finally we return the distance. So in this case, if you see, let me tell you the answer. For 11, the BFS function will return 2 as the answer. Okay, because after, remember, in the BFS function will not include 11. Okay, will include the nodes other than 11. Okay, so in this case for 11, the BFS function will return 2. Okay, because the longest possible traversal of one visited nodes that can happen from 11 is 2. Okay, of length 2. Similarly for 10, the answer will be 1 because there is only one node which is linked to 10. Okay, as simple as that. So for 11, the BFS function will return 2. For 10, the BFS function will return 1. Okay, 1. Yep. So this was all the BFS function, and then now the real starts. Okay, now the real stuff starts. See, this is the real. Yep. We are first. We'll try to find out circles. If a circle is found of length greater than 2, we'll capture its length as one of the possible answers. If the length is 2, then we'll start the BFS. Okay, for both the nodes. So this is our going to be our algorithm. So see this case. If the current node is already visited, continue. Do not include it further. Simply continue. Okay, as simple as that. Now, distance equal to 0, then I'm for each node, see, for each I, this thing will be newly created. Okay, visited nodes distance. So this will be basically help me to track if a circle is formed, how many nodes are there in the circle. Okay, just for that purpose. So I'm setting the current node equal to I. Now while visited node of current node is not equal to true. That is, if the current node is not visited, only then continue, otherwise break out of the while loop. Okay, as simple as that. So visited node of current node equal to true. See, this was not true initially. Now I'm making it true. Okay, next. Then I am in this particular dictionary. I am going to add the current node. For the current node, this is going to be the distance. Okay, distance is zero initially, but every time it will be incremented by one. Okay. See, after this, after allocating the distance, I'm just incrementing it by one. Okay, as simple as that. Now, remember, see, the basic idea of all doing all these things is I'm trying to find a circle. So whenever I find a circle, I will know how much nodes are there in that circle. Okay, this is the idea for that. Next, so next node is equal to favorite of current node. So see, I'm following the directions of the graph. Okay, so I'm finding what is the favorite of current node. See, always favorite of current node will be single node only. Okay, it will not be dual nodes. So whichever node it is, that will be my next node. Okay, so I'm just checking if next node is there. All this is if the next node already visited. If the next node already visited, that means we have identified a cycle. Okay, if the next node is not visited, see, if let's say this condition is not true, then this whole code will not be executed. Okay, the next node will become the current node. Okay, the next node will become the current node in the next iteration. Okay, as simple as that. But let us say this condition becomes true. Okay, the next node is already visited. Okay, let me show you how this happens. So see, first you will visit 5, then 6, then 7, then 4. After 4, the next node is 5. So 5 is already visited, right? So for 5 the distance will be 0, for 6 the distance will be 1, for 7 the distance will be 2, for 4 the distance will be 3, and then it will be distance plus 1. So when we come and check for 5, the distance will be 4 then. Okay, but since 5 is already visited, now let's see what the calculation is happening. See this part. Yep. Now a cycle is identified. We are now for trying to find out how many nodes are there in the cycle. So what we are doing, that the final list that we have, okay, I'm taking that and I am doing that. Yep, I'm subtracting from this. Okay, the visited node distance of next node. Okay, I'm subtracting with that. So this will give me basically. Remember, since this node is already visited, so maybe this is the node with which we started. Okay, this will be the starting node. So most likely this value will be zero. Okay, what you're seeing here, this value will be zero, and this value will be the highest value. Okay, so in this case, okay, in the case that I'm showing you for this 5, 6, 7, and 4, the answer in this case will be 4. Okay, that is there are 4 nodes in the circle. Okay, so the cycle length in this case will be 4. Okay, so now I'm just trying to capture that cycle length within the existing cycle length. Okay, so the longest cycle length is equal to max of the previous value of the longest cycle length comma the current cycle length that we have. Okay, in this example that I showed you 5, 6, 7, and 4, here the cycle length will be 4. Okay, that will update it to this. Okay, as simple as that. Now as I mentioned, the other case, see, this is the case number 1 where the cycle length is greater than 2. The other cases where cycle length equal to 2. Whenever the cycle length equal to 2, what we have to do? We have to do BFS. Okay, we'll see that now. So what I'm doing, see this case. Please pay attention here. This is the most important part. Whenever the cycle length equal to 2, what we'll do? We'll try to see whether for each of the nodes in that cycle can we expand further. Okay, as we saw here, right? See, 12 and 15 are there. They are forming a cycle of length 2. Can we expand further? That is, if any node depends on 12, can we do a reverse traversal and try to find those nodes? Just we are trying to do that. Okay. See this case. I'm going to form a set. Okay. In this set, what are the elements? The current node and the next node. Okay. These are the two elements. So in this case, what will the elements? 12 and 15 will be the elements. Okay. In this case, what will the elements? See this case. Let us talk about this. Here, 10 and 11 will be the elements. Okay. So 10 and 11 will be already there in the set. Okay, they will be there in the set already. This is the V. Okay. Next, what I'm doing, length involving length to cycles is equal to plus equal. Remember, we are always doing a plus. Okay. Idea here is if you see for both 8 and 9, then 10, 11, 3 and 2, and 1 and 0. For all of them, 2 will be added to the answer. Okay. Because as I mentioned, all of them can be accorded together in that table. Okay. They like see for 5, 6, 7, and 4, if we include this, then we cannot include any other node in the table. Okay. But in case of 8, 9, 11, 12, 11, 10, 3, 2, 1, 0, what will happen is we can accommodate all of them. And similarly for case of 11, 10, we can even accommodate the nodes which are depending on 11 and 10. Okay, as simple as that. We can do even that. Okay, so for that is not able to do. I will add 2 to the answer. Remember, this is a plus equal to. Okay, so yeah, I will add 2 to the answer. Why 2? Because the cycle found is of length 2. Okay, in this case 11, 12 will be part of that 2. Okay, so there are 11 and 10, so I'm adding 2 first. Okay, then I'm doing a BFS for the current node, and I'm doing a BFS for the next node. Okay, I'm passing V. Okay, so what is V? V is having these two nodes in the set. Okay, so the idea here is I want to discover nodes which are there in the other side of 10 for 11. Okay, so for 11 I will move in this direction, 12 and 13. Okay, similarly for 10 I will move in the other direction, which is 14. Okay, that is what I'm trying to do. Okay, so that will happen next. So I'm doing a BFS of the current node. I will doing a BFS for the next node. Okay, and then this will return me the length. Okay, for example, let me tell you this. For 11 the length return will be 2. BFS will return 2 because there are two that is the longest path from 11 other than 10 is 13 and 12. Okay, so the length is 2. Similarly for 10, the other side of 11, the number of nodes which are unvisited is only 1. Okay, which is 14. So that will give me the longest path. So see, something like this. See, from 15 we'll come to 17. Okay, that is we'll take the longest path. Okay, as simple as that. We'll find the longest path of nodes which are dependent on 15. Okay, As simple as that. Right, that will be added here. Yep, that will be added to the this. Okay, as simple as that. And yep, next this will keep continuing after that. Okay, the next one will be made as the current node, and this particular thing will keep continuing. And remember this part, for every I we are doing this. Okay, for every I we are doing this. If the node is not visited, if the node is already visited, we'll simply continue further. Okay, as simple as that. Ultimately, what we'll return, we will return the longest cycle length which we saw here. Okay, which we saw in this case. Yeah, this one longest cycle length, whichever longest cycle length is available, we'll try to consider that for the answer. Otherwise, we'll return this as the answer. Okay, where we are calculating all the circles of length 2, and we are also trying to expand them further if that is possible. Okay, in this case, if you see what is the answer, see for this example, can you tell me the answer? The answer is going to be 1 and 2. See, I will count. So how many pink circles are there? There are 4 pink circles. So 4 into 8, 8 plus 3 nodes, because 12, 13, 14 are 3 nodes. So 8 plus 3, 11. So answer for this particular case, okay, I'm talking about this case. If you see, the answer is going to be 11. Just add it in your the test cases and see the answer. Okay, the answer for this is going to be 11. I have also added that, I guess. Okay, maybe in some other stuff I've added that. Okay, yep, this was the one. Okay, this was the one. If you see, the answer is 11. Okay, in this case, I'm talking about this case. Okay, yep. So and yeah, this was all about this question. If you see the time complexity of the solution, it is going to be O of n solution, by the way, because see, all the nodes will be visited only once. Okay, as simple as that. They will be visited only once, and even only for BFS we will again be visiting them. So overall, it is a O of n solution. Okay. And if you talk about the space complexity, see this case what all we are maintaining. We are maintaining a misted set of n nodes. So this is obviously going to be O of n. Other than that, if you see, we are maintaining a reverse edges. Okay, that is all the edges we are trying to reverse it. Okay, but remember, since the edges are also see, number of edges is equal to number of nodes in this case. Okay, so even then it is going to O of n only. Okay, yep. And other than that, we are maintaining queues, but they are like temporary. At max, a queue can have only n elements. Okay, as simple as that. And similarly here also, we are maintaining this max can have only n elements, and similarly for other steps also. Okay, so yeah, overall it is going to O of n solution only. So yeah, that was all for this particular video. And yeah, I agree, like see, that's why I mentioned this kind of questions you can only solve when you understand the concept involved. Okay, without knowing the concept, I don't think it is the right thing to solve this kind of questions, because otherwise, see, you will start doubting yourself. Okay, you lose that confidence. So learn this topic, maybe learn these examples, what are the possibilities, and try to learn them why it is so, and then maybe start solving it. I also did the same. I first learned like what is happening in this question. Okay, what are the cases possible? As I mentioned, there are two cases possible. A cycle is being formed of length greater than 2. Other case, when cycle is formed of length 2. Okay, in the second case, there is sub case. In the sub case, what will happen? We have to expand further. Okay, for each of the nodes involved in the cycle of length 2, we'll have to do a bfs to find which all nodes depend on this in a reverse direction. Okay, if for 11, if you see, we are going to follow a reverse edge. Okay, so that's why if you see, can you quickly tell me why I created this reverse edges? I need them to do the bfs. So if you see in the bfs, basically we are only doing the reverse edges. Okay, so if you see, we are only talking about reverse edges, but in this solution, okay, if for other than the bfs, if you see, we are following this. Okay, we are following, yep, the western nodes. Okay, as simple as that. So yeah, but I did that. Okay, yeah. Yeah, this is the one. Okay, favorite node of current node. So if you see, we are following the favorite in this, that is we are moving forward in the terms of edges, but in this we are doing reverse edges. Okay, because as I mentioned, whenever a length 2 circle is formed, we will have to go back and see how many like maximum longest path that can achieve starting from 11 and 10 in this case. Okay, so for that we have to go in a reverse direction, right? Yeah, and that was all for this video. This was a harder question according to me, and yep, only with I guess only if the examples are given properly, only then maybe if these diagrams are given properly, only then I guess we will be able to form the solutions. We will identify the pattern. We will be able to form the solutions. But anyway, take this as a learning challenge. Try to learn this kind of topics, and just know that yeah, this kind of question also exists. Mostly, like see, this level of question will be asked in online assessments. Like we have LeetCode constants in the question number 4. This kind of questions will be asked. So don't worry if you're not able to solve them. Like try to learn whatever is possible from this kind of questions. I agree this is hard. This cannot be solved without taking some hints. But yeah, don't think in that way. Your aim should be to do as much as possible, right? So in this case, we learned bfs, we learned some other stuffs also. Try to like know those things so that if possible you will be able to solve this kind of questions. But remember, in the real interview, if such a question comes, you will get lot of hints. Okay, you will get a lot of hints. The examples will be better. In this case, if you see the example, it doesn't convey any meaning. Okay, at least they should have given the diagram properly, like they are just showing the edges and all that. Okay, but they have not done that. Okay, so at least those things should be given so that you can get the idea of what to do. Okay, in this case, otherwise you should have a pen and paper with you where you are drawing yourself and trying to see what happens. Okay, if you don't have a pen and paper, it's difficult to like get the bigger picture of what is happening. Okay, so that was all for this particular video. I will give this a solution in the comment section. You can take it out and try to learn what is happening. But yeah, like you will have to know this concept, otherwise you will not be able to solve this question. So yeah, fun, that was all for today. And if you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.